Hello everyone, welcome back. So in this video we are going to learn about new concept of digital electronics, that is combinational circuit. Combinational circuit. So what is a combinational circuit? So what are the basic elements? So basic elements of combinational circuits or logic gates. Logic gates. That means the combinational circuits are designed by using the logic gates. So they are form the basic elements of the combinational circuit. Okay. So the definition comes like this. So when logic gates are connected together, when logic gates are connected together to produce certain outputs, certain output combinations for certain input combinations, for certain combination of inputs without storage, then such type of circuit is called as combinational circuit. Okay, so such type of circuit is called as combinational circuit. So logic gates are connected together to produce certain output combinations for certain input combination. So what does it mean? Suppose take an example of gray to binary conversion. Gray to binary conversion. So this we have learned when we are discussing about the topic codes. So gray to binary conversion we have seen theoretically. So if you want to design that circuit, that means if you give some gray code at the input side, then you should obtain the binary code at the output side. So that means for certain input combinations of gray code, the corresponding binary code must be obtained at the output side. So this is possible, or this design is possible by using logic gates. So such type of circuit which designs this gray to binary conversion is called as gray to binary code converter. Okay, such combinational circuit which designs this gray to binary conversion is called gray to binary code converter. This is an example of combinational circuit. So this is how the combinational circuit works. So without any storage, that means no storage is involved in this. That means in combinational circuit at all times the output combination depends on input combination only. So it does not depend on previous inputs or any other thing. So it depends only on present input combination. Depending on the input, you will get the corresponding output. So that is depending on the gray code here in this example, depending on the gray code you will get the corresponding binary code. Okay, so this is about combinational circuit. So next the design steps. So the design steps involved in designing the combinational circuits. So first of all, the first point is the definition of design. So the definition of design, what does this mean is you have to be in a position to know so what we are doing or what we are designing. That means, so for this example we are designing a combinational circuits which converts gray code to binary code. Similarly, you can design an adder circuit which adds 2 bits. Okay, so that definition, that means what is the functionality, so we'll call it as functionality. the functionality of the circuit which we are going to design, you have to know that. So that is the first step in designing the combinational circuit. So after knowing the functionality, that means what you want to design, then we have to know the number of input and output variables. So after knowing the functionality or the type of circuit which you want to design, then you have to know how many input variables, or we'll call that as literals. In digital circuits we'll call that as literals. So how many literals at the input end and output end are required in order to design the circuit. Okay, so that is the second step. And third step is assigning letter symbols to input and output variables. So assign some letter symbols like A, B, C, D. So if you are designing gray to binary conversion, so we'll design G1, G2, G3, G4. 4-bit gray code is converted into 4-bit binary code B1, B2, B3 and B4. So this type of assigning is called as assigning the letter symbols, which is the third step in designing the combinational circuit. Next is deriving the truth table. Okay, so deriving the truth table. So what is truth table? For all the input combinations, what is the possible output? What is the possible output combination is given by this truth table. So truth table involves the relationship between input variables and output variables. So input variables and output variables relationship is defined by this truth table. And the next step, the fifth step, is after obtaining the truth table, we have to perform the Boolean expression simplification. Boolean expression simplification for outputs. For all the output variables, we have to find the simplified Boolean expressions by using different techniques. So generally we'll use K-maps, which is the easiest method for obtaining the simplified output expressions. Okay, so this is the fifth step. And the last step is design the circuit by using logic gates. Design circuit using logic gates. So using logic gates you can design the circuit. So that will be the final step. Okay, so these are the design steps which we have to follow for designing any combinational circuit. Okay.